Today we're going to review 1- and 2-step equations. You've probably done this before, but we're going to formalize what it takes to solve 1- and 2-step equations. Our ultimate goal in solving equations is to find the missing value, right? Find our solution, or the number that the variable equals. Well, sometimes you can look at these very simple equations and immediately the solution comes to your mind. And when it does, that's fantastic. Go with that. But sometimes when you get more complicated equations, the missing value is not immediately clear. And in those cases, it's necessary to unwrap the equation and find the missing value manually. And by unwrapping the equation, I want you to picture wrapping a gift. Sometimes you'll put the gift into a box, you'll seal the box, you'll cover the box in wrapping paper, and maybe even tie it with a bow. Well, the person receiving the gift has to go back through your process, undoing each part in order to get to the gift. They'll untie the ribbon, take the wrapping paper off, open the box, and then take the gift out. Well, solving equations is no different. We're going to reverse the process, which in this case is order of operations, to get down to where our variable is isolated. Or in other words, the variable's by itself, and then we'll find our solution. Well, the items that we're going to undo today are coefficients and constants. A coefficient is multiplied to a variable, and a constant is generally added or subtracted to a variable. We need to undo those processes to get down to our solution. Our first equation, x plus 3 equals 9, I'm betting that you can look at that equation and know the solution right off the top of your head. And like I said, that's fantastic. But humor me for just a second as I go through a formal process. X is our variable. It is not by itself because it's being added to 3. Well, I need to do the opposite of add 3 to isolate my variable. And of course that would be subtracting 3. But equations are a little bit tricky. Equations are like a balance scale with the fulcrum or balance point on the equal sign. When you have a balance scale, whatever you do to one side of the scale, you have to do to the other to keep it balanced. And equations are exactly like that. If I subtract 3 from one side of my equation, I have to do the exact same thing to the other side of my equation, keeping in mind that that equal sign is our balance point to keep my equation balanced. Now on the left-hand side, 3 minus 3, of course, those are gone, right? 3 minus 3 is 0, and x plus 0 is just x. I'm left with only x on the left-hand side of my equation, and on the right-hand side of my equation, 9 minus 3 leaves me with 6. X equals 6 is what we call our solution because I just isolated the variable and also in the process found my missing value. When you looked at that, didn't 6 pop into your mind? 6 plus 3 equals 9? Of course. We already knew that our missing value was going to be 6. We're just looking at the formal process so that when we get to more complicated equations, this is going to make it easier. What about m minus 4 equals 10? Have you found the missing value yet? Well, to formalize the process, like I said, I'm going to put in my dividing lines, separating my equation into left and right halves. M is not by itself because 4 is being subtracted from it. So I need to undo the subtract 4 to solve my equation. And of course we do that by adding 4 to both sides of our equation. One of the most common mistakes that students make in solving equations is trying to add 4 twice on the same side of our scale or our equation. Remember that when we balance our scale or balance our equation, what we do to the left, we have to do to the right. Negative 4 plus 4 equals 0, and so they basically cancel each other out, and I'm only left with m on the left. 10 plus 4 leaves me with 14 on the right. And now that my variable is isolated or by itself, I have my solution of m equals 14. 14 is our missing value. 14 minus 4 equals 10, right? So, like I said, we're just formalizing the process. Now, instead of adding or subtracting a constant, I have a coefficient. 5 times x equals 40. Again, I'm going to split my equation into left and right so that I can keep my equation balanced. X is not alone because it's being multiplied by 5, so I have to undo the process and divide both sides by 5. 5 divided by 5 reduces to 1, and 1 times x leaves me with only x on the left-hand side of my equation. On the right-hand side, of course, 40 divided by 5 equals 8, so x equals 8 is both my solution and my missing value. What if your coefficient is a fraction? A lot of people start to freak out when they see fractions in their equation, but there's no need. Since 2/3 is a coefficient, and we divide by coefficients, I would basically divide both sides by 2/3, and that looks a little complicated. Until you remember that dividing by a fraction is the same as what? Isn't that the same as multiplying by its reciprocal? Of course. Flip the fraction upside down and multiply. Don't forget to do the same process to both sides of your equation. On the left-hand side, 3 times 2 gives me 6. 2 times 3 gives me 6. My new fraction is 6 over 6, which reduces to 1. And 1 times x is just x. On the right-hand side, I can't multiply a whole number to a fraction, but I can change that whole number into a fraction by putting it over 1. So really I'm multiplying 8 over 1 times 3 over 2, multiplying straight across the numerator and straight across the denominator. I get 24 over 2, which is equal to 12. X equals 12 is my solution and also my missing value. Now, what if there's both a coefficient and a constant? Think for just a second about unwrapping that gift. When I have a coefficient and a constant, just like unwrapping the gift, you have to go in the opposite order. We have to do the same thing with order of operations to solve equations. I have some multiplication and some subtraction in this equation. In order of operations, it tells me that multiplying and dividing comes before adding and subtracting. So to solve an equation to get x by itself, I have to go in the inverse order, which is telling me I have to add or subtract before I multiply or divide. To solve equations, we have to focus on this inverse order of operations. Let's put in our dividing line. Since I have to add or subtract first, that tells me I have to get rid of the subtract 5 first. So I'm going to add both sides by 5. Then I need to undo the multiply 7. So I'm going to divide both sides by 7. and I'm going to end up with x equals 2. X equals 2 is our solution. How about 5 minus 6x equals 17? Which value is your constant and which value is your coefficient? It's a little bit harder when the order is reversed, but remember, a constant is the number without the variable. I need to get rid of this positive 5 first. Negative 6 is my coefficient. We'll take care of that last. To undo a positive 5, and I could reverse this order and put negative 6x plus 5 if it makes it easier. But first of all, I've got to get rid of that positive 5, so I'm going to subtract 5 to get that done. And I have negative 6x equals 12. Then I can divide by negative 6, and I end up with a solution of x equals negative 2. Be careful that you take care of your constant before you take care of your coefficient. How about m divided by 3 plus 5.4 equals 8.2? Just because there's decimals here does not change the process. We're still going to have that dividing line. We're still going to subtract before we multiply or divide. When I subtract 5.4 from both sides, I get m divided by 3 equals 2.8. This next step can be done in probably 2 or 3 different ways. I could change m over 3 into 1/3 m and use a fraction coefficient. But to make this just a little bit easier, to get m alone, we have to undo divide by 3. And what's the opposite of divide by 3? Wouldn't that be multiply by 3 on both sides? Sure, that's still going to eliminate my 3's so that m is isolated or by itself, and 2.8 times 3 is 8.4. m equals 8.4 is our solution. Last but not least, let's take one more look at a coefficient that's a fraction. We're still going to have our dividing line. We still have to do our add or subtract before we take care of our coefficient. So I'm going to add 4 to both sides, and I'm going to be left with 2/3 x equals 7. To undo a coefficient that's a fraction, remember we multiply by the reciprocal. 6 over 6 is equal to 1, and 1x just gives me x. 7 over 1 times 3 over 2, multiplying straight across the numerator, is 21. Straight across the denominator is 2. That gives me 21 over 2. That fraction cannot reduce, so I could either choose to write my answer as a fraction, or I can go ahead and do the division. 21 divided by 2 is 10.5. All right, I think that wraps it up. Don't forget that you can rewind and go back and look at examples again. But for now, I'm going to wish you a great day, and I'll see you next time.